This is day one of Advent of Code 2025 in C Sharp. This challenge is called Secret Entrance. The elves have good news and bad news. The good news is that they've discovered project management. This has given them the tools they need to prevent their usual Christmas emergency. For example, they now know that the North Pole decorations need to be finished soon so that other critical tasks can start on time. The bad news is that they've realized they have a different emergency. According to their resource planning, none of them have any time left to decorate the North Pole. To save Christmas, the elves need you to finish decorating the North Pole by December 12th. Collect stars by solving puzzles. 2 puzzles will be made available on each day. Second puzzle is unlocked when you complete the first, and each puzzle grants 1 star. You arrive at the secret entrance to the North Pole base, ready to start decorating. Unfortunately, the password seems to have been changed, so you can't get in. The document taped to the wall helpfully explains, due to the new security protocols, the password is locked in the safe below. Please see the attached document for the new combination. The number has a dial with only an arrow on it. Around the dial are the numbers 0 through 99 in order. As you turn the dial, it makes a small click noise as it reaches each number. The attached document, the puzzle input, contains a sequence of rotations, 1 per line, which tell you how to open the safe. A rotation starts with an L or R, which indicates whether the rotation should be to the left, toward lower numbers, or to the right, toward higher numbers. Then the rotation has a distance value, which indicates how many clicks the dial should be rotated in that direction. So if the dial were pointing at 11, a rotation of R8 would cause the dial to point at 19. After that, a rotation of L19 would cause it to point at 0. Because the dial is a circle, turning the dial left from 0, 1 click makes it point at 99. Similarly, turning the dial right from 99 1 click makes it point at 0. So if the dial were pointing at 5, a rotation of L10 would cause it to point at 95. After that, a rotation of R5 could cause it to point at 0. The dial starts by pointing at 50. You can follow the instructions, but your recent required official North Pole secret entrance security training seminar taught you that the safe is actually a decoy. Actual password is the number of times the dial is left pointing at 0 after any rotation in the sequence. So for example, suppose the attached document contained the following rotations. So the dial starts by pointing at 50, L68 goes to 82, L30 52, R48 goes to 0, L5 to 95, keeps going on, there's another 0 and then another 0, so the password in that example is 3. So, analyze the rotations in your attached document. What's the actual password? Okay, so let's get started. So the first thing we're going to do is grab our input for this challenge. We are then going to go to our day one txt. So the directory layout I have is Advent of Code 2025 C Sharp. So inside of the C Sharp is the day one. Then outside, in line with the C Sharp directory, we've got input and we've got the day01.txt in there. So this is the relative pathway to get to the input. So something which has been a little bit annoying in preparation, terminal within VS Code hasn't been working. So I'm going to have to actually run things from here. So to run that will be .NET run day01.cs, and we saw it around there. Okay, so back to this challenge. Our starting position is 50, so int position equals 50. And we are wanting to count how many times the dial is turned to 0. So we'll do int 0 count 0, because we haven't counted it yet. We're going to iterate through each of the lines, so for each var line in input. And the first thing we want to do is grab the direction. So that will be first character of the line. So we'll do car direction equal to line 0. And then the remainder of the string is the actual number. So we will do int distance is equal to int.pass, and it would be line.substring 1. So let's just do a console.writeLine on the distance, and let's see if that's working. Do that, bring up the terminal, run it. Alright, need capital L, write line, and we can see the numbers being printed out. So that is all good. So what we want to do, actually, let's take a look at the numbers first. Are there any weird numbers in here? Okay, so there are large numbers like this. So of course, the only possible turn you can do, well, if you have a number that's large enough, you're essentially just going around multiple times, but you don't really need to actually record all the times you go around. So it'd make sense to actually do a modulus on it. So modulus 100. So if you had the number 100, and you turn it 100 times, it'd end up in the exact same spot as you were before. So it makes sense to modulus it, make it 0, or do a modulus 100, which would make it 0, so you don't actually rotate it. So that is what we'll do. We'll do distance is equal to distance modulus 100. So what we'll do now is look at the direction. So that is R or L. So let's do if direction is equal to R, and then we'll just do an else condition here. So if it's R, we are doing position equal to position plus direction, and we want to do another modulus 100. So let's say you had 98 and you do turn 3 times, that would make it 101. By doing a modulus 100 on it, we'll turn it to 1. So you do a modulus there, and we will do the same thing here, minus direction, but there is potential for it to go to a negative number when really it should be positive. So we do if position is less than 0, position plus equals 100, just to bring it back up to the positive, flipping over from like 1, 0, 100, or 99, whatever it is. So we've got that, and what we should do now is at the bottom here, if position is equal to 0, position 0, count plus plus. And then at the very end, we do console.write line 0 count. So that should be everything for part 1, but let's run it and see an error to help if I could actually write things correctly. So now we'll try again, and we got 70. So let's go back to here, enter in 70 and see if that's worked. That is not quite right. Full input. Okay, so we've done that wrong somewhere. Something I might try for debugging purposes. Let's print out what line we're on. So let's do line, and see if that, was it a right line? Oh, whoops, there's a C all the way up there. Okay, let's see that. Oh, I see the mistake I made. I did direction instead of distance. And it's kind of interesting that it did work, but because it's a character, can do digit math with it. So let's change that back to distance. And now hopefully that will work properly. Ooh, 1150, 1154. That sounds high, but based on the number of lines in here, very well could be that high of a number. So 1154. And that was correct. So now let's go on to part 2. You're sure that's the right password, but the door won't open. You knock, but nobody answers. You build a snowman while you think. As you're rolling the snowballs for your snowman, find another security document that must have fallen into the snow. Due to newer security protocols, please use password methods long hexadecimal until further notice. Remember from the training seminar that method long number means you're actually supposed to count the number of times any click causes the dial to point at 0. Regardless of whether it happens during rotation or at the end of one. Following the same rotations as in the above example, the dial points at 0 a few extra times during the rotations. So basically, if your starting number is greater than the ending number, where it's turning to the right, then it passes over 0. Or if the starting number is less than the ending number you're turning to the left, then it passes over 0. So that is basically what we are doing. So we will get started. I'm going to just change this to part 1. We'll do that. Then I'm going to copy this into part 2. Okay, so we've now got part 1, part 2. So what we'll do is if position equals 0, or actually we'll do int previous position is equal to position. If previous position is, let's do greater than position, and direction is equal to R, then we can do or previous position is less than position and direction is equal to L. Then that should cover when it turns over. So you got previous position here rotating to the right, so it goes say 99, 0, 1, that would work, or you're on 1 rotating to the left. Okay, I think that should work. So let's go here and rerun it. Okay, let's get rid of these console write lines. Try it again. Okay, we got 2902 and it doesn't seem right. Oh, actually this won't work because I've done, if you're turning, say it's 500, it's going to go around multiple times. So I need to get rid of this here, and could I do something as simple as plus equals 1 times distance divided by 100, something like that. Or distance, or do this, plus 1. Actually, no, this doesn't work because you could rotate, go over 0, and then end up having this condition being wrong. So we're actually going to have to completely change this part of it. Okay, so what we actually want to do is get rid of all this modulus. So position plus equals, keep previous, plus equals distance, turning to the right, and then minus equals for the left. And we can do, what would the math be for this? So turning to the right. Actually, something we can do, which I was trying to think of like a more mathematical solution, but something we could do is just, because the numbers are small enough, we could just do a for loop over them, just add it. I think you could just do this and then 0 count plus equals position divided by 100, and it's going to be position time, I think it's the same thing, both of them actually. And then so do the 0 count, then position is modulus equal 100. I think that might work. What I'm going to do is return back here and grab this and see if we can get it right. So what was the answer for this one? So new pass will be 6. If we update this and we run, let's see what number we get. Okay, well that's obviously not correct. Alright, it could be a negative number, so just do times -1 and then do that, maybe? No. Alright, I did that. I need to do if position less than 0, position times equals -1. Then we change this back. And that needs to be inside of here. Now let's see if that works. Still just 1. Actually, no, this doesn't make sense. If we're turning to the left, and let's say we go to -10, it would then be going to 10. So doing times equal -1 does not work. Actually, no, I should go back to what I had before. Get rid of all this. Do this. Int, what would we call this? Just do current count or something. Do this. And then if this number is less than 0, times that by -1. And then we do count like this. I think that should work now. Still 1. Maybe I need to look at this again. So left 68, it passes over once, points at 0. So 1, 2, 3, 4, 5, 6. Okay. Maybe I need to do some console right line logging. Start previous position, and that will be just position. And we'll do count, current count. Let's run that and see what it gives us. So, okay, so I didn't do it these. Interesting. Oh, okay, yeah, that doesn't work at all. Yeah, okay, that makes sense why it doesn't work. I want to see, so we're doing position. What is previous position dot divided by 100? So I got a number to look at. Okay, that's all 0. I guess something we could do. Let's do total int full rotations is equal to distance divided by 100. So full rotations, we can do 0 count plus equals full rotations. That's the first thing to do. And distance can be just equal 100. We could then do this part, get rid of this, and go back to the original one. Actually, not the original one, but the one which I was thinking of initially. Equals 0 or previous position greater than position, and direction equal to R. And then there's also the next one, which is less than L. Let's see what that does. Okay, we've got an error. Current count doesn't exist because we don't need that anymore. Let's try again. 2. So let's bring back console dot right line, previous position, position. We'll add direction as well. Let's just take a look at things. Okay, so worked on -48.0. Okay, that only worked on this. Okay, let's bring that up to here. So let's see. Right. Need to do the modulus here, and then that should work. We're still getting 3 though. What we need to do is if position is less than 0, position is equal to 100 minus, well, no, we just need to do a plus equals 100. Now that should work. Okay, we're getting 8. Well, let's take a look back to here. 50 is 82. How is 8 possible? Okay, let's put that to here. Okay, included these ones. And then let's do previous position does not equal 0. And now we're getting 6. Hopefully we've finally got it. So 3, 6. Let's change this back to the actual input. Now let's rerun it. 6819. That is a larger number than before. 6819. And that is the correct answer. If you like this video, make sure to like and subscribe.